all technology is biased. Right? One of the things Cathy O'Neil has said in her book Weapons of Math Destruction is that algorithms are opinions embedded in code. Right? So if you are a techno-chauvinist, you think, oh yeah, the computer is going to make a decision that is superior, that is neutral, that is unbiased or objective. That is not at all true.
All right, I am here today with Professor Meredith Broussard. Thank you so much for being on Urgent Futures.
Thanks so much for having me. It's great to be here.
I feel like we have, there's so much that I want to get into relative to technology and AI in particular, but I'd like to actually start with your background so that people understand where you're coming from as it relates to all these juicy, buzzy topics.
Sure. So I am the author of a book that is out in paperback now. It's called More Than a Glitch: Confronting Race, Gender, and Ability Bias in Tech. And I wrote this book based on my own experiences as a computer scientist and also as a journalist. So I started my career as a computer scientist. I quit to become a journalist. And now I do both as a data journalist. Data journalism is the practice of finding stories in numbers and using numbers to tell stories.
Amazing. I've already have notes of questions that I want to follow up on. But I feel like the way you orient us in More Than a Glitch, I think is a really effective way for us to kind of get into the conversation, which is proposing this idea of techno-chauvinism. So would you be able to describe what that is and why you see that as an important critical lens for approaching questions of technology in society?
This is one of my very favorite things to talk about. So, techno-chauvinism is this idea that technological solutions are superior to others. And what I would argue is that we need more nuance than that. Uh, Technology is not necessarily superior. We need to think about using the right tool for the task. So sometimes the right tool for the task is absolutely a computer. Like my smartphone, you will pry it out of my cold, dead hands. But sometimes the right tool for the task is something simple like a book in the hands of a child sitting on a parent's lap. Right? One is not inherently better than the other. So we need to let go of techno-chauvinism in order to make better decisions about appropriate uses of technology. And this comes to the fore when we're talking about artificial intelligence. AI is just math. It's very complicated, beautiful math, and it is not the solution for absolutely everything.
Mm. You also, I'm not going to ask you to do the sort of foundation work you do in helping folks understand the way a model works. But maybe if you could do a very condensed version, because it's such, I found, a clear, helpful way of understanding AI and multidimensionality in models. So yeah, if you could give like a little bit of a compressed version of that. And also sort of related to that, strategies for understanding AI when you're not a data journalist or a computer scientist or what have you.
I am totally invested in this idea that we need to bring more people into the conversation around AI. So when we're talking about AI, most people, their minds go to something from Hollywood, like Terminator or, Her, Ex Machina, Star Wars, Star Trek, something like that, which makes total sense because Hollywood is really good at telling stories, and our brains are better at recalling stories than they are at recalling facts and statistics. Right. So we need to fight against this urge that we have to conflate the AI that we see in the movies and the AI that is real and is, affecting people's lives today. So, most AI systems that we are seeing nowadays are what's called machine learning systems. It's a really bad name because it suggests there's a little brain inside the computer, which there absolutely is not. So, a machine learning system is just a system that does computational statistics. What's going on inside a machine learning system is it's being built in a particular way. It's built the same way every time. What we do is we take a whole bunch of data, we dump it into the computer, and we say, computer, make a model. Computer makes a model. The model shows the mathematical patterns in the data. And then we can use that model to do all kinds of cool stuff. Like we can make decisions, we can make predictions, we can generate new text, audio, video, what have you. right? So AI, machine learning, is really, really powerful, but it is based on data about the past. And because of that, it is not necessarily the best tool for making decisions that will lead us toward a different, better future.
Amazing. And your book picks up with questions of bias broadly, but as it particularly pertains to race, gender, and ability. So I'd love to kind of open up that discussion. I guess maybe the orienting question there is why those categories and what is important for us to consider when confronting bias through technology in those categories.
Well, one of the interesting things that I kind of came to realize through my research is that all technology is biased. Right? One of the things Cathy O'Neill has said in her book Weapons of Math Destruction is that algorithms are opinions embedded in code. Right? So if you are a techno chauvinist, you think, oh, yeah, the computer is going to make a decision that is superior, that is neutral, that is unbiased or objective. That is not at all true. So I actually prefer a frame that's given to us by Ruha Benjamin in her book Race After Technology, and that's the idea that automated systems discriminate by default, right? So there's a lot of discrimination out there in the world already. And all of those patterns of discrimination are found in the data that we use to train AI systems, right? They're found in the models because the models are just learning the mathematical patterns. They're learning to discriminate. And then so what these models do is they take that discrimination and intensify it. They weaponize it. And so they discriminate by default. We actually have to put in mechanisms to make them not discriminate, right? So they are not inherently more objective or in any way unbiased. They are inherently biased.
Mm. And you pull from some historical examples to help us kind of understand how this plays out in AI. I was particularly struck with the Kodak example that you share in the introduction, but also referencing the history of statistics, referencing Linnaeus. Could you share some of those examples about how math and science, though often assumed to be closer to truth or objective, are actually structured on um, social norms and social values?
It has a lot to do with the way that elite math as a profession works. Elite mathematicians for a very long time have been able to get away with anything. Like the thought was, oh, they're so important, they need to just like sit in the ivory tower and think about math all the time, which is really great if you are an Ivy League mathematician, but not so great for the rest of us. And so there's this kind of disregard for the responsibilities or the expertise of everyday life that is common among mathematicians, and then computer science is basically a descendant of mathematics, right? So it's an attitude that gets passed down and then gets turned into techno chauvinism. Right. So, one of the examples that I keep coming back to over and over again is the example of the racist soap dispenser. Uh, so, listeners, I don't know if you've seen this video, but it's really incredible. Just Google racist soap dispenser. What happens is there are two men. They're in a bathroom and they're trying to use a soap dispenser. One of the men has really light skin. One of the men has really dark skin. So the man with the light skin goes and puts his hand under the soap dispenser, and the soap comes out. It's an automatic soap dispenser. And then the man with dark skin puts his hand under the soap dispenser, and nothing comes out. Right. So maybe you think, all right, well, it ran out of soap, or maybe it just broke in that moment. There's lots of reasons it could not be working. But then the man with dark skin gets a white paper towel, runs it over under the soap dispenser, and then the soap comes out. Right. So the soap dispenser is racist. Now, I don't think that's intentional. I don't think that the makers of the soap dispenser set out to say, all right, I am going to make an automated soap dispenser that only works for people with light skin. I do not at all believe that. I think what happened is that the soap dispenser was probably designed by a small and homogeneous group of people who happen to have light skin. They tested it on themselves, on maybe their friends and family, and said, oh, works for us, must work for everybody. which is a really common cognitive fallacy. It's a really common assumption. But it's a good example of why we really need diverse groups of people creating and testing our technologies, because when you have a small and homogeneous group of people making technology, then the tech they create gets the collective unconscious bias of the group creating the technology, right? So Silicon Valley has a very long-standing diversity problem, and when you are in a small and homogeneous group of people, you're not seeing the collective unconscious bias of your group, right? So having a greater variety of people in the room when these decisions are being made, when these products are being created, is going to lead to better products because they will work for a wider range of people. But I should say it's also not enough to have a more diverse group of people in the room. We need to empower people to speak up, and we need to pay attention when somebody from an historically marginalized group says, "Hey, this is not working," or "Hey, there's some bias embedded in this process."
Mm. There was this example earlier this year, of course, with Google Gemini, you know, producing historically inaccurate figures, such as
Black Nazis.
Black Nazis, exactly. Um,
Yeah.
and that's an example of reinforcement learning by human feedback, and an example of Silicon Valley attempting to address a problem, let's say in a way that didn't work out very well. Could you diagnose what they got wrong in that moment? And again, building off your last comment, what would you advocate for them considering looking to the future to sort of not make problematic to have problematic outputs like that?
Well, so this was a an attempt made in good faith to increase the diversity of the outputs of a generative AI model, right? So Google's Gemini is an image generation model. The problem was that it was outputting images of all white people, and Google was criticized for this. This again is a default that the machine learned based on the training data that was used to make the model in the first place. And so, obviously there are people with all kinds of shades of skin in the world, and so Google heard this criticism that the model was putting out, a disproportionate number of white people, and so they said, "All right, we're going to put in a diversity filter where there's going to be a range of skin tones represented in any image." Okay, well, that leads to things like what people are calling historically inaccurate images, or when you ask it for a picture of a Nazi, then it gives you a black person, a black Nazi, and they're obviously we're not black Nazis. So Google quickly turned off this feature. So I think it's an example of imagining that it is possible to code our way uh, out of a really complicated social issue, right? And so one of the points I make in the book is that we can write code for a lot of things, but when we run into something like the racist soap dispenser or the generative AI that makes pictures of black Nazis, like we need to look at not only this code failure, we also need to look at the underlying social context. Okay. So, like, why are you making a generative AI that makes pictures of Nazis in the first place? Right? Why are you making a generative AI that makes pictures and does not, uh, and that exploits the labor of the artists who made the art and put it on the internet? Why are you doing that without compensating the artists and the content owners? Right? We need to look at the larger social context when we run into situations like this. And the reason the book is called More Than a Glitch is because in coding, we have glitches and we have bugs, right? And so bugs are things that you pay attention to. They're features that you fix. You develop a ticket for a bug, but a glitch is like a blip. It's less important than a bug. And you're like, oh, it's kind of a spasm. Like, it's not really that important. Can I reproduce it? I'm not really sure. I'm just going to ignore that. Right. So when the machine acts racist or sexist or ableist, that often gets treated as a glitch, not as a bug, not as a big problem in the system. And I'm arguing that there are these big problems in society that computer scientists are not necessarily equipped to make decisions about, and that we can't necessarily write computational rules about.
Mm. Yeah, I'm sort of jumping around, but as you spark different things, um, you talk about elegant code and how elegant code itself as an idea embodies much of the bias you're describing in the book, and also the hubris that computer scientists will often approach the development of AI and other technological tools with. I'd just like to invite you to speak to that.
Mm-hmm. Yeah, I mean, I write code. I've been writing code since I was 11 years old. Like, I do love elegant code, right? But elegant code is this kind of normative aesthetic, and it is does not necessarily serve us well. So one of the ways that I started thinking about this is when I started thinking about the way that gender is represented inside computational systems. So it turns out that we are all living with very 1950s ideas about gender inside databases. Because back in the day, uh, computers, of course, started being used in the 1960s. Some of the first applications were for the census, for analyzing political polls. And computers at that point were these huge things that took up entire rooms, right? And they were really, really expensive. So up until well, I guess actually we still have to think about cost, but anyway, memory is pretty cheap now. It used to be really expensive. So when I learned to code in the 90s, uh, you had to be really stingy about memory because memory was so expensive. So this normative aesthetic developed where you were really stingy about the size of the variables that you used, because the smaller your program is, the less memory space it's going to take up to run, and then it's going to run faster, and you know faster is better in terms of code execution. So we think about the different kinds of variables we can use. We can use a string, right, which has letters, which is this big. We can use a number, which is about this big, and then we can use a binary, which is a 0 or 1. It's like this big, right? And so the size is like the amount of size space that it takes up inside the computer's memory. And gender uh, was generally stored as a 0 or 1, because there was this 1950s idea that gender was fixed and it was either male or female, right? Well, now we know that gender is a spectrum. And well, it would actually be better to represent gender as a string, not as a binary, because, you know, it's a spectrum, it's a field that should be editable. Um, it's actually not editable a lot of the time in a lot of computer systems, which is kind of staggering. Um, but the the problem is there's interaction with legacy systems, right? So the systems we use today have to talk to much older systems. So like at your bank or at your insurance company, they are likely using systems that somewhere deep down are the same systems that they designed in the 1960s. Right? So banks and insurance companies are still sometimes using a programming language called Fortran, right? Which barely anybody talks about anymore. And Fortran programmers get paid a lot of money because there's so few of them. So anyway, the legacy systems have to talk to the up-to-date systems, and the variables have to be of the same type. Otherwise, they don't work, right? You can't pass a number to a function that's expecting a string and vice versa. So all of these systems have to be rewritten like way deep down. in order to represent gender as something that is not a binary, right? And that is something that takes commitment, it takes money, it takes time, and not every organization is willing to commit to that. I mean, we all have enormous technical debt. The way that I like to think about systems is I kind of think about that. Um, I think about a ramshackle house, right? That keeps getting additions put onto it. Like one year somebody puts on a garage, and then the next year somebody like staples on a sunroom, and then on the top of that they build a sleeping porch. Like people come in, they build different things onto the ramshackle house. Really, it would be better to like knock the whole thing down and build a new house from the ground up. But nobody does that because that's really expensive and time consuming, and then you don't have access to the house. So uh, that's where we are in terms of technical debt. And I'm just interested overall in thinking about the ways that social decisions get embedded in our technological systems.
Mm, I love all of that, and I appreciate it. I remember Jaron Lanier talked about MIDI, the music file format, um, being something that was put together for a very niche use case, and then of course it becomes the foundation for how music is stored digitally, much to the chagrin of many modern musicians and professionals in the music industry. You also ran into this in with the medical system, and so I'd love to, if you're willing to share your experience with AI being involved in a cancer diagnosis and the journey that sent you on.
Well, so it started when I was diagnosed with breast cancer. I am totally fine now. I should say I'm very grateful to the folks who took care of me. And what happened was I kind of cope with disaster by reading a lot. And so I was reading my entire electronic medical record, like even the parts that nobody ever expects you to read. And what I discovered was a note in my chart, and this said, "Oh, this scan has been read by Dr. So and so and also by an AI." I thought, "Oh, that's really weird. Like, what did the AI find? Who wrote the AI? What's the bias in this AI? Does this have any implications for my care?" And then I kind of forgot about it because, I had cancer, I was busy. But then I came back to it after I was a little bit healed. And I said, all right, I'm going to devise an experiment. I'm going to take my own scans, which I know have cancer because, I had cancer. I'm going to take my own scans. I'm going to run them through an open source AI in order to write about the state of the art AI based cancer detection. Right. And it was so much harder than I thought it would be. There were all of these unexpected obstacles, and also the system did not work the way that I expected, which I think is similar to the feeling that a lot of us have when we start digging into AI and we realize, oh yeah, the thing that I thought the AI would be doing, that's not actually what the AI is doing. Right. So if you have read mainstream media coverage of cancer and AI, you might have developed the opinion or the impression that AI based cancer detection is right around the corner. And it is not, right? People are experimenting with it. But the way it works is that the doctor puts in a diagnosis, and then after they've entered the diagnosis, they can see what the AI's prediction is. The AI is not giving a diagnosis, it is just identifying an area of concern on the scan. And it's giving, the one I used was giving a score between 0 and 1, not a, you know, 20% chance that this is malignant, just a score, right? So it's it's pretty complicated, uh, and there are all of these. There's just a lot of misconceptions out there about AI and cancer. I can also say that as somebody who was diagnosed with cancer, I do not want a future where a machine uh, is doing the diagnosis and scanning, right? So when you are facing this kind of health decision, you do not want a world where you like walk up to a box and you insert your body part and that tells you, oh yeah, probably cancer, or nope, no cancer. Like, you want a doctor, you want medical professionals who are telling you exactly what this means, what the implications are, because it's terrifying. So this AI enabled future around healthcare is, I mean, I'm sure there are good uses of AI, and I would be absolutely on board with, things that improve people's access to healthcare, uh, improved earlier diagnosis so that cancer is not a death sentence. Like, I'm totally on board with that. But I think we need to be realistic about what our current technologies can and can't do.
Mm. I also spoke with Professor Nita Farahani, who wrote about neurotechnology, and
Hmm.
she really was clear in specifying that these technologies can be used for good, but those are things that enable and empower individual liberty. So an individual being able to use these various tools without then those the outputs of using them, the data, being surveilled by governments or corporations, which is mostly how it happens today. Would you say that your approach to AI follows a similar line of thinking?
Yeah, Nita's work is terrific. And I would say that I am enthusiastic about some uses of technology, but where we are right now as a kind of as a community, as a species, like, we need to stop and repair all the things that are broken, right? So we need to stop layering on more technology because the really basic stuff is extremely, extremely broken. So in my last book, Artificial Unintelligence, I wrote about the situation with textbooks in schools, right? So this is, especially relevant today because we're in this era where people are thinking that, somehow online school is going to be sufficient. Like, it is not. But people imagine that we're going to be able to just use online resources for everything, and also that online resources are free, which they are not. But you especially see this when it comes to school. So kids in school nowadays in the US are expected to take these standardized tests, right? Well, the knowledge that you need to pass the standardized test is generally contained in a book or in a curriculum that is published by one of the big educational publishers, right? And these are the same people who write the tests, right? So if you want to pass the test, what you need to do is read the book, right? What are we giving kids in school? We're giving them all of this like free stuff off the internet that is not necessarily on the test. And then we're also expecting teachers to teach to the test, but not giving the teachers the materials that they need for the kids to theoretically learn the material that's on the state mandated standardized tests. And school districts don't have enough money to buy the extremely expensive textbooks and e-learning materials and what have you that go with the curricula that match the tests, right? So we would really be better off if we're going to use the standardized test system, what we need to do is just stop putting more technology in and make sure that every kid has a textbook, right? And after every kid has a textbook, let's then do the e-learning resources and the laptops and the tablets and the this, that, and the other thing. But it doesn't have to be this hard. And using technology, like, people are not that good at using technology on a grand scale. Like, we're good at using easy technology, but when it comes to like a whole school, right, that's what, like 1,000 kids and teachers all using bandwidth and electricity and dropping things and breaking things and you know running through the sprinklers with their phones in their pockets. Like, there are just so many opportunities for things to go wrong. Like, books are actually pretty durable uh, when it comes to the things that kids do.
Mm. Well, shout out books first of all. Love
Yeah,
books.
books are great.
Yeah. That also reminds me of something that you discuss in More Than a Glitch, which was automated checkout and the ways that um, that automated systems like that, in addition to interrupting human labor, also offset costs onto the public. So
Mhm.
yeah, wanted to ask you to share a little bit about that.
Yeah, so automated checkouts are basically shoplifting machines. They so stores that go to automated checkout have like then immediately have tremendous problems with shoplifting, right? Some of it's intentional, some of it is accidental. Uh, and we have this situation in New York City now where I live where the drugstores have started locking everything up, right? So you want to go and like buy shampoo, but like the shampoo is in a a locked thing behind the plexiglass and you got to push the button and like wait for somebody to come over with the key to unlock the shampoo. Well, okay, so the executives at the drugstore did this because they're like, oh, we're having such a problem with theft, right? We need to keep all the products safe. Well, guess what they're also doing? They're also doing self checkouts, right? And so people are not connecting the dots in, I think, a productive way. And a much easier way to reduce theft is to have a cashier, right? Have human beings in the store. Like we're all living in a community, and having people in community reduces things like shoplifting.
Mm. You're also opposed to the use of facial recognition technology. Could you describe
Oh
what
yeah, I don't
facial
like that either.
could you describe, I mean, people can probably gather what it is if they're not familiar, but if you could briefly describe what it is, and yeah, why you're opposed to it.
So one of the things I think about when I think about facial recognition is I think about high risk and low risk uses of technology, right? So I am opposed to facial recognition in high risk contexts. A low risk context might be something like the facial recognition that you use to unlock your phone. Like it doesn't work for me half the time. It's not really a big deal. I put in my passcode and I go along with about my business, right? So that would be a low risk use of facial recognition technology. That's fine. But a high risk use of facial recognition technology might be police using facial recognition on real time video surveillance feeds. Because here's something about facial recognition. We talked about the racist soap dispenser. Well, facial recognition is a kind of souped up version of the technology that's in the racist soap dispenser. And it is also racist, right? So facial recognition has been found to work more effectively on people with light skin than dark skin. It works better on men than on women. Generally, trans and non-binary folks are not recognized by facial recognition systems. And then there was this project called Gender Shades, in which scientists did an intersectional audit of facial recognition systems. They found that it worked best of all on men with light skin, and it worked worst of all on women with dark skin, right? So let's think about, well, if police are using facial recognition on real time video surveillance feeds, who's going to get caught up? Who's going to get identified as a criminal more often, right? Because the facial recognition does not work that well, right? It misidentifies women and people of color, especially people with darker skin, more often, right? And we already know that policing technologies are weaponized against communities of color, against poor communities. So I would argue against using facial recognition in policing at all. I sometimes people ask me, okay, well, what is a good use of facial recognition? I mean, I don't really know. I'm sure, uh, you know, I'm sure somebody has one that they like, but I just don't know what it is.
To unlock your phone seems benign, but of course, even that could go incredibly sideways depending on, um, what implementation of facial recognition technology is being used and by whom.
Yeah, I mean, I think biometric data in general. I'm not sure why we got to the point where people are really eager to use it because all data leaks too. So eventually there's going to be some kind of breach where the biometric ID system that is used on people's phones, like it's going to get hacked, like all the data is going to leak, and you can't change your face, right? You can't change your fingerprint. Like that's really sensitive data. And so if I were if I were running a tech company, I would not want to be responsible for keeping people's biometric data safe.
Mm. This also intersects with the questions of AI when used in prediction that you surface and that continue to sort of iterate in various moments across the news. Could you talk about in what ways AI is being used in prediction, and again, why that extends, these forms of bias that already exist in the world?
Well, we really want to know the future, right? I mean, that's just an essential human desire. Like we really want to know what's going to happen. We're not good with uncertainty. You know, the fact that we're so into astrology, like astrology gives us these, these ideas about what's going to happen in the future. Like that's one of the things that's fun about it, right? Uh, but fundamentally, nobody knows what's going to happen in the future. So we're always just struggling with that as human beings. And one of the attractions of machine learning is that it gives you the ability to make predictions. And so, with some degree of statistical certainty, you can say, all right, I think this is what's going to happen in the future, which is totally great, like really satisfying, but also runs into all these issues of bias. So one of the examples that I look at in the book is the case of mortgage approval algorithms. So automated mortgage approval algorithms. The Markup, which is a really terrific algorithmic accountability news organization, did an examination into automated mortgage approval algorithms. And what they found was that these algorithms were 40 to 80% more likely to deny borrowers of color as opposed to their white counterparts, right? And in some metro areas, this disparity was more than 250%. Totally horrifying, right? So let's think about, well, how was this mortgage approval algorithm built? Well, what they did was they took data about who has gotten mortgages in the past and put it into the computer and said, computer, make a model. Computer made a model. Model showed mathematical patterns in the data. And then they said, all right, make predictions about who should get mortgages in the future. And well, that was mostly white people. Okay. So the programmers did not see the patterns in the data as well as the model did. And what those patterns showed was a pattern of financial discrimination. It showed a pattern of bias previously in lending. And we know that that has happened in the US. We know the US has a really long history of financial discrimination. We have a history of redlining, of residential segregation, of all kinds of bad stuff. So, really, a better system would be not to give humans all of the power or give algorithms all of the power. It would be something in between, right? So, it would be humans with algorithmic checks on their decisions. It would be algorithms with human checks on their decisions, and also a system where decisions can be reversed, right? Where people are empowered to look at an algorithmic decision and say, oh, yeah, that was a bad decision. I'm going to change it, right? That doesn't happen often enough because technochauvinism, people believe the computer uh, when they really shouldn't.
Mm, mm. Speaking of technochauvinism, you write that the easiest strategy is that we need to start calling bullshit on claims about future technology and a rosy tech-enabled future. And you also outline a 3-step method for doing so. So when thinking about people who maybe absently are assuming or believing in techno-chauvinistic ideas or platforms or tools, yeah, walk me through this sort of bullshit detection method as like a first line of defense to that.
Well, I really like the book on bullshit. I mean, I recommend it to everybody, and I think that you just need to uh, be skeptical about claims about AI. And also, would urge people to familiarize themselves with some of the known problems in AI. One of the social media influencers I like on this topic is Casey Fiesler. She does AI policy news briefs every week. And a lot of these are from I think it's called the AI Harms database, which is this crowdsourced list of ways that AI goes wrong. Right? There's thousands and thousands and thousands of examples in there. And so I do look at that sometimes just to kind of keep up with what the latest disasters are. Um, and so one of the claims that you can be really skeptical about is claims about self-driving cars and how safe they're going to be, because they are absolutely a menace.
Yeah, yeah, lots to say on that front, and with regard to um, that particular CEO. One of the sort of mythologies that you approach with, let's say, an arched eyebrow, is the idea and the sort of proliferation of the idea of the black box. What is the black box, and why do you approach that with no small degree of skepticism?
I think the black box is about gatekeeping, right? It's about it's a like we talk about algorithms as black boxes. I think because back in the day, computer scientists didn't know how to explain what was going on in an algorithm, and uh, it's really hard to explain complex technical terms in plain language. I mean, for me, that was the hardest part of writing this book. And at any rate, when you want to get out of a conversation, you say, "Oh, it's a black box. Like, just pretend it's a black box. Like, there's a goes into and it comes out and there's just stuff that happens inside, right?" And so it was a way of gatekeeping, of saying, "All right, well, I'm doing fancy computer science. You wouldn't possibly understand it," but also they didn't know how to talk about it. So uh, I mean, this is also happening now, like with social media platforms. There's a book called Meganets by David Auerbach, where he writes about how social media platforms are actually so complicated that the engineers themselves don't know what's happening in them. Right. So same thing with LLMs. They are these like they're doing multidimensional statistics, and the engineers building them don't really understand what's happening, so they just say, "Oh, let's just abstract it out." So yeah, and nobody likes to really admit that they don't know what's going on, but honestly, nobody knows what's going on inside these things. But we do have ways that we can audit these black boxes, that we can crack them open a little bit and understand a little bit of what's happening in them, right? So we don't need to consider them unknowable. We just need to acknowledge that it's kind of hard to figure it out. But it's really fun to figure out what is going on inside a black box of an algorithm. So I think of it like I think of my car, right? I would like to just get in my car and drive and never think about what's going on in the engine. But I know that something will eventually go wrong in the engine of my car, and I am going to have to take it to the mechanic. If I do not know at least a little bit about the engine of my car, then the mechanic is going to rip me off, right? So I need to learn a little bit about how my engine works, and I need to learn a little bit about diagnosing things in my car engine in order to have a better relationship with my mechanic, and and not get ripped off, and also not, drive around with things broken all the time. So it's the same deal with algorithms and computers. If we're going to use computers and algorithms for so many things, like there's no turning back. Like, we are in the digital age. It would be absurd not to use computers, but we need to not pretend that they're magic, right? They are tools. They are boxes. They're machines. They do math. Math is not appropriate for solving every problem. It's only appropriate for solving some problems, right? And we overall need to increase our computational literacy so that we can diagnose what's going wrong inside black boxes of algorithms and make better decisions and be better participants in democracy.
Mm, I so appreciate that. Well, to that end, you reference public interest technology as a way of thinking about using technologies in ways that promote algorithmic justice, promote social equity. What is public interest technology, and how are you thinking about it?
I mean, public interest technology is one of the things I end the book with. It's really, it's kind of one of the solutions, I think, to the social ills the technology has brought us. So PIT is exactly what it sounds like. It's about making technology in the public interest. You can be a public interest technologist inside or outside of government. So outside of government, public interest technologists are people like data journalists and algorithmic accountability reporters who are testing algorithmic systems like the automated mortgage approval system. Or Julia Angwin has a new news organization called Proof News. They are doing benchmarking of large language models. So they tested them around the US presidential election and found that more than 50% of the time, the models were giving inaccurate information about the US presidential election. Now, that's a pretty shocking number. More than half of the time, the chatbots are giving wrong information about the election. That has really big implications for democracy, right? So we've got that kind of public interest technology happening outside of government. Inside government, public interest technologists are, working for the government. There are places like AT&F. And a public interest technologist inside the government might do something like strengthen a state unemployment website so that in the next pandemic, when there are millions of people filing unemployment claims all at the same time, the site doesn't go down. Right. So, and another good example is the recent FAFSA disaster. They redesigned the financial aid form that kids fill out and send to colleges, and the colleges use that to determine financial aid. But when all the kids were applying to college this year, the FAFSA form wasn't ready, the new FAFSA form, and so it caused all of these delays, caused all of these, all of these problems, and it really did not have to be that way.
Mm. You spoke about it a little bit before, but I want to pull it back into the conversation. This idea of algorithmic auditing.
Sure. Algorithmic auditing is basically the process of opening up black boxes and auditing algorithms for bias, for discrimination. Um, so we have a lot of methods for doing this. It is a practice that is relatively new. The way we think about algorithmic accountability is we can think about accountability reporting, right? So the traditional mode of accountability reporting is you would look at what is a company saying and then what is a company doing, right? But algorithms are increasingly being used to make decisions on our behalf. So this accountability function of the media has to transfer onto algorithms and their makers, right? So we have algorithmic accountability reporting. So what you do as an algorithmic accountability reporter is you audit systems and you in part look at what a company is saying that they're doing, and then you look at what they're actually doing. Right? So this is really relevant when it comes to LLMs or chatbots, large language models, generative AI. The companies like OpenAI had said, "Oh yeah, we have these really strong protections in there about election misinformation, and if somebody asks a question about the U.S. presidential election, we're going to send them to these particular sites." And then the reporters went in and said, "Okay, how often is that happening?" And it was not happening as often as it needed to.
Mm,
Right? So that's
mm.
a good example.
Yeah, I want to
You want
build
to
on
check
these.
out that story? It's at Proof News. I forget if it's .org or .com.
Yeah, and Proof News has been doing amazing work, and yeah, shout out to the markup for the ongoing incredible work that they've done.
Indeed.
I want to open up a bigger conversation here around your view on the future of journalism, and I think there's kind of a few bullet points in that. But maybe to build off the last conversation, what do you see as the current state of data journalism? What are the things that you're keeping an eye on? What are the things that you're excited about in the field? And also, what are the sort of areas of concern that you have?
So I think that journalism needs more money, right? Period. Full stop. Like, so if you want to support journalism, if you want to support real news, not fake news, buy a subscription, buy advertising, uh, we need more money going to journalism outlets. We do not need more money going uh, to online advertising firms. Like, it's that simple.
Mm,
Like,
mm,
we need more journalists, we need more journalism, and we need it to be prioritized over, you know, pink slime news.
mm. Well, especially when thinking about like journalism in general is expensive. Good journalism is expensive.
It is.
A- And data journalism is like another order of magnitude of training that the individual journalists need to sort of undertake, because you have to essentially become to develop expertise in multiple domains, both technical and conceptual or social. But then also for the outlets to sustain that type of work is incredibly expensive. I've been wondering, kind of looking at these, the way in which OpenAI is striking deals with various outlets like The Atlantic. Um, how are you seeing that dynamic between the work that data journalists need to be doing and now OpenAI, which is this mighty resourced organization establishing deals that lock in publications to using their tools in particular ways?
Well, so something that is really interesting about the content deals that OpenAI has struck recently is that the is that ChatGPT is hallucinating links to the biggest investigations from these partners. Right. So there was a story, I think it was in 404 Media today, about the reporter went in and asked ChatGPT about some of the really big news stories from OpenAI partners, and the links or summaries were complete hallucinations, right? So, I mean, the LLM technology is only good for really limited uses, and the people who are very excited about using it for journalism like are are mostly you know just misguided about what they think its possibilities are. um, it's useful for really mundane stuff. And one of the interesting things is that we've all been using AI for years without realizing it, right? There's something like 250 different machine learning models that get activated every time you do a search on Google, right? So you've been using AI and not knowing it for forever, right? Every time you do a recording and then do an automated transcription, like you would on a Zoom call, or maybe use something like Otter.ai, like that's AI. it's it doesn't feel special, right? Like people kind of expect AI to like they expect using it to feel special, but it's actually like a pretty mundane technology. The first time you use ChatGPT, like it's really exciting. Like the first 10 minutes are so thrilling, and then you realize, oh yeah, this is kind of mundane.
Mm. What do you make of the test reel folks who are concerned about the prospect of artificial general intelligence and a singularity where humans would be displaced? How are you thinking about that discourse?
I I mean, that's not my lane at all. I think that conversations about existential risk are a distraction from the really concrete harms that people are experiencing at the hands of AI right now.
Mm,
And I think we should focus on what's real, not what's imaginary.
mm. I so appreciate that. Uh, Last sort of question on this front is a broad one, which is, since the publication of this book, obviously a lot has happened in technology and in AI in particular. have there been any moments or developments that have happened in the interim that you've seen that have deepened your thinking or changed your thinking or just sort of provoked a new line of thinking? Yeah, I'm just curious about that.
Well, I'm a little annoyed about the timing. So, had they released ChatGPT like 6 months earlier, then I might have written a whole chapter about it. But it did not work with my publication schedule. And so I did write about GPT in More Than a Glitch, kind of in passing. And like the real revolution there was the ChatGPT interface, right? So they've had this ability to make the model respond using human-like language for a while now. But the chat interface, where there was a web page and it had like some rudimentary graphic design on it, like that was the real thing that made that technology take off. Right. And so I kind of wish that it had happened a little bit earlier, because then you know, I would have been able to sneak it in ahead of the print deadline. But print deadlines, they are what they are.
Indeed. Is there any new work that you can speak to or reference at this time in this conversation?
I am working on a couple of projects. One of the things that I got really interested in when I was writing Glitch was the idea of medical racism. And so, currently in the middle of writing a scholarly paper on medical racism and how to audit algorithms in order to uncover racism inside automated diagnostic systems. So I will be sure to send a copy. Maybe we can have another conversation once that comes out.
Oh, I'd love that. I'd love that. I can't wait to read it. All right. I have three questions I like to ask every guest to close out each episode. You've obviously referenced some of the information that you might say, so feel free to repeat yourself or extend to something that you've already said. What is one thing you wish people paid more attention to?
I wish that people would pay more attention to the way that technology has failed, the way that people have made promises about technology and then walked them back. Uh, I think once you start paying attention and hearing the kind of commonalities of the narratives, and you realize that tech companies tend to overpromise and underdeliver, it makes you a little more skeptical. It makes you a better consumer.
Hmm. What is one resource you would recommend for making better sense of reality?
Oh, better sense of reality. Great question. I have gotten involved recently in an organization called IPIE, the International Panel on the Information Environment. I think there is a lot of great scholarly work coming out of that community. I am also really involved with a community called Critical Race and Digital Studies. And there is a syllabus online. If you Google Critical Race Digital Studies syllabus, there are a bunch of really fantastic resources there.
Amazing. And finally, what is one moment when your sense of reality was disrupted?
I would say that one moment I think about a lot is a story from Artificial Unintelligence, which is when I was little and I got an erector set, which is this set of like metal braces and little screws and nuts and tiny child-sized wrenches. And one of the projects was to build a robot, and I was so excited. I was like, "All right, I'm going to build this robot, and it's going to come to life, and it's going to be my new best friend, and it's going to be so great." And then I built the robot, and I put the motor into the robot, and I thought the motor was going to like bring him to life, and then the motor didn't work. And I like flipped the switch and I, fiddled with the batteries. I was so sad. I got my mom. I was like, "Mom, the motor is not working." And she was like, "Do you switch the batteries?" And I said, "Yes." And she said, "Did you turn it on and turn it off again?" And I said, "Yes." So she came and looked at it and she did all the things and she was like, "Oh, the motor's broken." And so then we, sent off to get a new motor and la la la. But the robot just never worked the way that I thought it was going to. And I realized there was a really big gap between what I imagined the technology could do and what the technology actually did. And I try to keep that in mind when I am thinking about future possibilities of technology, because human imagination is so much more powerful than reality.
Mm. That is a perfect note to close the conversation. Lastly, any places people can find you to learn more about your work?
I am at meredithbroussard.com. I'm Mary Broussard on all the social platforms. And then More Than a Glitch, Confronting Race, Gender, and Ability Bias in Tech is available everywhere that books are sold.
And is a must read. So appreciate that book, and I so appreciate you taking the time to be on Urgent Futures.
Thank you so much.
This podcast is edited and produced by Adam Labrie and me, Jesse Damiani. The podcast is presented by Reality Studies. You can learn more by visiting realitystudies.co. And if you appreciate the work I'm doing, please subscribe and share it with someone you think would enjoy it.